This is FRQ2 from the 2024 AP Calculus exam. This problem is primarily about position, velocity, and acceleration. This is calculator active, so we will use our graphing calculator as needed. If you appreciate the content, please give it a like. A particle moves along the x-axis so that its velocity at time t greater than or equal to 0 is given by v of t equals the natural log of t squared minus 4t plus 5 minus 0.2t. Part A. There is one time t equals t sub r in the interval between 0 and 2 when the particle is at rest, not moving. Find tr. On the interval between 0 and tr, is the particle moving to the right or to the left? Give a reason for your answer. This problem has two parts to it. The first part is to find time tr when the particle is at rest. That means when v of t is equal to 0. This problem is calculator active, so let's enter v of t as y2 in the graphing calculator and use that to find where v of t is equal to 0. By the way, just to keep myself organized, I always let y1 be the position function, so like x of t in this case. I let y2 be the velocity function, and if there's an acceleration coming, I let that be y3. Okay, obviously that is not mandatory, it's just something I do to help myself remember which equation is which. I recommend resetting your calculator at the beginning of each problem by hitting second plus 712. Again, that is second plus 712. Fresh calculator. So go ahead and hit y equals and enter the velocity equation right here as y2. So here is our velocity equation typed in as y2. We need to find where the velocity is equal to 0, specifically on the interval from 0 to 2. We need to adjust the window to only show the interval from 0 to 2. So hit the window button and let's let x min be 0 and change x max to 2. By default, well, if you reset your calculator, then your y min is set to -10 and y max is +10. Let's leave it like this for the moment and hit graph and see what we've got. We need to find this 0 of the velocity function. There are two ways to do it. I'm going to show you my least favorite way first. We can hit second trace and choose the 0 feature, option number 2. This is going to trigger this left bound, right bound menu. So where it says left bound, just make sure the pointer is to the left of the 0 and hit enter. And now it says right bound, slide over somewhere to the right of the 0 and hit enter. And then where it says guess, go back close to the 0 and hit enter. So that's one way to find the answer. Now I'm going to show you the method I actually prefer, which is to graph the x-axis itself by going back to y equals and letting y1, or really any of these, equal 0. Hit graph again. Now you can see the x-axis is shown as this blue line. Now the 0 will be the intersection point between the red and the blue. So hit second trace again, but this time choose option 5 for intersect. I prefer this method because it does not trigger the whole left bound, right bound interaction. You can simply move the pointer close to this point of intersection and hit enter 3 times. Enter, enter, enter. You get the same exact answer, but I find this to be simpler. Let's store this value into a letter on the calculator just in case we need it later. So hit second quit. And this is just a good habit to get into. Hit the store button. Actually, hit the X value and then the store button. And I'm going to store this into letter C. So alpha C enter. We may not need it, but if we do, It's all of these good decimals are right here in letter C. Pro tip: the College Board will accept 3 decimal places. However, many students try to round to 3 decimal places and they lose a point by rounding incorrectly. So my recommendation is to always use 4 decimal places and never try to round. So let's use 1.4256. That's the answer to the first part of the question. We have found TR, the time on the interval from 0 to 2, when the particle is at rest. Now we need to determine whether the particle is moving to the right or to the left on the interval from 0 to TR. The sign of velocity tells you whether the particle is moving to the left or to the right. Specifically, the particle will be moving to the left if the velocity is negative, and to the right if the velocity is positive. So let's take another glance at the graph on the graphing calculator and see whether the velocity is negative or positive on the interval from 0 to the value of TR that we just found. This 0 is TR. So notice that on the interval from 0 to TR, the velocity function shown here in red is positive. It's above the x-axis. We say the particle is moving to the right on the interval from 0 to TR because v of t is positive. Part B. Find the acceleration of the particle at time t equals 1.5. Show the setup for your calculations. Is the speed of the particle increasing or decreasing at time t equals 1.5? Explain your answer. This is another two-part question. First, we have to find the acceleration of the particle at time t equals 1.5. The acceleration at 1.5 will equal v prime at 1.5. This will be super easy to do on the graphing calculator. Remember, we typed the velocity equation in as y2. So evaluating v prime at 1.5 means evaluating the derivative of y2 at 1.5. To make the derivative show up, we hit Math and we choose option 8. Go ahead and call it dx, and we need to do the derivative of y2 since that's where we stored the velocity function. To make y2 show up, hit alpha trace and hit 2 for y2. We need to evaluate this derivative at x equals 1.5. Kabam! Negative 0.9999. Yes, you would get credit for putting -1, but I'm going to stick to my rule of always using 4 decimal places and not trying to round. The second part of the question is we need to determine whether the speed of the particle is increasing or decreasing at time t equals 1.5. We have learned that the speed of a particle is increasing if velocity and acceleration have the same sign, and speed is decreasing if velocity and acceleration have opposite signs. We just found that the acceleration is negative at time t equals 1.5. We just need to see whether the velocity is also negative or is it positive. Let's use the graphing calculator to find v at 1.5. Since we stored the velocity as y2, we just need to evaluate y2 at 1.5. Again, to make y2 show up on your calculator, you hit alpha trace and hit 2 for y2. To evaluate y2 at 1.5, simply put 1.5 next to y2 in parentheses and hit enter. Kabam! It's negative. Be sure to record this in your work. V at 1.5 is equal to negative 0.0768. Now we can say the speed of the particle is increasing at t equals 1.5 because the velocity at 1.5 and the acceleration at 1.5 have the same sign. Be careful, I'm allowed to use a for acceleration right here, but only if I defined a at the beginning as being equal to v prime. Let me emphasize this one more time because this is a common mistake. If you just say a at 1.5 equals without saying a at 1.5 which equals v prime at 1.5, you will not earn this point. Part C. The position of the particle at time t is x of t, and its position at time t equals 1 is x at 1, which equals -3. Find the position of the particle at time t equals 4. Show the setup for your calculations. When they ask us to find the value of a function, but they only give us an expression for the rate of change, we use the first fundamental theorem of calculus. In words, the first fundamental theorem of calculus says the value of the function at b is equal to the value of the function at a plus the change in value from a to b. In general, the value of the function at b is f at b, and the value at a is f at a. But I want you to memorize that the change in value from a to b will be the integral from a to b of f prime. In this case, they are asking us to find the position at time t equals 4. So we need to find x at 4. But we need to start from a known position, which they give us right here. We know the value of x at 1. So x at 4 will be x at 1 plus the integral from 1 to 4 of x prime. Well, of course, x prime is the velocity. So x at 4 will equal -3 plus the integral from 1 to 4 of v of t dt. You gotta love these calculator active problems. All we have to do is type this into the calculator. Don't forget that we entered velocity as y2. Okay, we need -3 plus. To make the integral show up, we do math and choose option 9. We want the integral from 1 to 4 of velocity, which is y2. To make y2 show up, we hit alpha, trace, and hit 2 for y2. And just put a dx on it. And kabam! -2.8028. That's it for Part C. Again, I recommend that you always use 4 decimal places and don't try to round. Part D. Find the total distance traveled by the particle on the interval from 1 to 4. Show the setup for your calculations. Make sure you have memorized this formula. The total distance traveled by a particle from A to B is the integral from A to B of the absolute value of velocity. On the interval from 1 to 4, the total distance will be given by the integral from 1 to 4 of the absolute value of velocity. On a calculator active problem, this is super easy. Just remember that we entered velocity as y2. To make the integral appear, hit math and choose option 9. We want the integral from 1 to 4. Now, we need the absolute value of velocity. The absolute value function is under the math button, and you have to switch over to the num menu, and it's this first option right here. Just hit enter. And we want the absolute value of velocity, which we entered as y2. To make y2 appear right here, hit alpha, trace, and choose option 2 for y2. Finish it off with a dx, and kabam! 0.9581. That's it for Part D, and that's it for FRQ number 2. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.